Not somewhere, it's over there. Okay. So the first thing that we're going to do, all right? So I'm going to, if I could, okay, maybe not. No, it's okay. So we're going to find A first. Okay, maybe this is good enough. Okay, we're going to find A first. So which is the terminal closest to A? P3, yes or no? Right? The closest, so we're going to find point A first. Right? And the closest terminal is T3. Okay. And we only have one Q, right? There's only a Q on this side. Now, you can see that over here you have web. You can have, I'll call this web number 1, web number 2, web number 3, and web number 4. And web number 3 and 4, right? And 1 and 2, they are connected, but 2 and 3 are not connected. Okay. If you no, I can't say that. If with reference, okay, with reference to the geometric centroid, right? At point A, right? P3 is the closest what? Terminal. So the first moment of area has to be from the closest terminal. Okay. So we are going to find the first moment of area at point Z at point A. So the width, we are given that the thickness is 2 millimeters, right? And the depth, so from here to here is 50, right? So 50, so the distance from here to here is 1 millimeter. So this is about 24. And then the y bar will be equal to 24 divided by 2. Okay. So QZ at point A is 2 times by 24 times by 24 divided by 2 is equal to 576. So this is also equal to 576 times 10 to the power minus 9 meter cube, right? So the shear at point A, so the V is equal to 5,000. The I is 133.76. The first moment of area, and then this one you only need to divide by 2 millimeters. Okay, so this will be equal to 5,000 times by 576 for 5,000 times by 576 power minus 9 divided by 133.76 power minus 9 divided by 2 power minus 3 is equal to 10.766. 10.7, there's something I pressed wrong. So 5,000 times by 576 power minus 9 divided by 133.76 power minus 9 divided by 2 power minus 3. 2 power minus 3. 10.76. Yep, times 10 to the power 6 Pascal. Okay, so this is straightforward. Now the thing is, we have to look at point B first. Now we have to look at point B. Right? Point B is over here. Now, point B, the direction, right? The arrow is also shear flow direction is also vertical pointing upwards. And the terminal is from where? The closest terminal is from where? T3. Can you see that now? So in order to find this first moment of area, right, you have to use above the Q is positive, below the Q is what? Negative. Okay. Now, some of you might ask me, Eugene, why we cannot use T1? We cannot use T1 because the direction of the shear flow is not the same. It's going upwards, whereas from T1, they are all pointing at T1, right? If you look at T1, coming to point C, they're all pointing what? Downwards. So you have to obey this rule over here. T3 is the original or is the terminal that the shear flow or your analysis has to start from. Okay, so that is using T3. So at point B, okay, point B, the terminal is also T3, and then your Q. Okay, so QZ at point B will be equal to positive 2 times by 24 times by 24 divided by 2, and then minus 2 times by 24 times by 24 divided by 2. The positive part, right? So I'm going to draw over here. So the positive part, this is the first moment of area that's positive, and over here, this is the first moment of area that's negative. When that's the case, this will be equal to what? 0. Okay, so therefore, the shear stress at point B is equal to 5,000 multiplied by 0 divided by 133.76 times 10 to the power minus 9 divided by the thickness of 2 times 10 to the power minus 3. This will be equal to what? 0. Okay. Now, the next one we see is we look at point C. Okay. Okay. Now, if you look at point C, now it's not just which is the closest terminal. It is the what? Direction of the shear flow, right? So if T1, if you look at point C, which is over here, the original terminal, it has to be from where? From T1, right? It has to be from T1 because it's flow and the direction is vertically coming down. If it's from T3, when it reached at point C, the direction over here is what? Horizontal. So for this case, it cannot be from where? It cannot be from T3. It has to be from T1. Okay. So if we were to look for T1, so at point C, okay, at point C, right, at point C, right, is coming from T1. Okay, and then T1, what you realize from T1, you are going to have what? Box beam. Because you have Q going in one side, right? And you have the other one going the other side. Okay, so this is a box beam analysis, right? So this is, let me see, that is our point C. Okay, is that our point C? Yeah, our point C. Okay, so that is our point C. Okay, so again, you got our centroid, right? So you have Q is positive over here, Q is negative over here. Okay, so the first thing we do, I mean, there are two ways of doing it. Okay, so the first way, we can use Q We can use the positive, or what do I call it before? We can use the Q, taking Q from P1. Okay. So now we have to find the first moment of area. So if I'm going to partition the structure this way, right? So at the top, Q, the width is 20, the depth is 2, and this will be equal to multiplied by 25. Okay, because the 50 is through the center over here. You can see the dimension. Okay. Then you have plus the left and right 2, and then you have 25 plus 1. The width is 2, right? And then you have 25 plus 1 is 26. And then you have 26 divided by 2. So this is for left and right, right? This is for the thickness, or this is for the width. This is for the depth, and this is for the Y bar. Okay. And then the next one is minus, right? Because at point C, now you have to consider the negative part. So the width is equal to, so you got left and right 2. The width is 2. Now the depth down here, right? So at point C is 24. Multiplied by 24 divided by 2. Okay. So this will be equal to, you have to be really careful with this. 2 times 25 is equal to 1000. Plus by 2 times 2 times 26 times by 26 divided by 2 is 1352. Wait, 20 times 2 times by 25. Okay. 2 times 2 times by 26 times by 26 divided by 2. 1 minus by 2 times 2 times by 24 times by 24 divided by 2 is 1152. So this will be equal to 1000 plus by 1352 minus by 1152 is equal to 1200. Okay. So 1200 millimeter cube. Okay. Or 1200 times 10 to the power minus 9 meter cube. Okay. So the shear stress at point C, right, by doing this configuration, so the V is equal to 5000. The Y bar sorry, the first moment of area, the centroid, the second moment of area. Remember to divide by 2 because it's box beam. And then you have to divide by 2 times 10 to the power minus 3. So this will be equal to 5000 times by 1200 power minus 9 divided by 133.76 power minus 9 divided by 2 divided by 2 power minus 3 is equal to 11.214 times 10 to the power 6 Pascal. Okay. Now the second way of doing it is, remember, you can also use the rule that the first moment of area cannot cross the centroid. Remember, right? We can also use the rule that the first moment of area cannot cross the centroid, right? So when that is the case at point C, you can also take, okay, you can also take the analysis just from, I'll show you where, okay. just from here to here. Okay, just from here there to there. Okay, so the answer, so the when we you do that, the answer will be